Good morning. Today we'll discuss about solar cell. So, so we'll revise once the previous topics. Photodiode and pin diode till students join. So, in photodiode or pin diode, basic principle is converting optical energy into electrical energy. Okay. So, in that photo and pin diodes, we have used semiconductor material characteristics of solar cell. What are the applications of solar cell? And what is the preference, main preference to choose the materials used in solar cell? Of course, semiconductor materials we use, but in that also, uh, how to choose? That is how they instead of how they prepared. What is the construction of solar cell? We'll see. For that, already I have drawn um, solar cell in these regions should be absorbed by that material reflection of light. If you take silicon, the basic phenomenon, in case of silicon, it has 30% reflectivity. Light is incident on that, 30% of the light is reflected back. Okay, so to have maximum absorb, these are the metal grids. Here, anti-reflective coating, right? So what anti-reflective coating does? It it absorbs maximum of light energy into the material. Generally, these anti-reflective coatings, silicon nitride, okay, or titanium oxide, these are or those materials are taken as anti-reflective. Okay, so here this is P-type material. P-type material. This is junction in few books. Same. There is no difference here between this PN junction or here metal earth. Here is same. Both are same. Okay, to prepare to create the PN junction. Right. So we started at metal grids, right? And this anti-reflecting layer, these are the channels where the light is incident, and these are PN diode, and this is another metal contact. This is also metal contact. Back side of it also metal contacts will be there, right? This is construction of solar cell, and here we need the photon. How much energy need that for that photon we have to take? That photon should create, okay, so that photon should have sufficient energy so that it creates electron hole pair in this PN diode, simply solars. Okay, and you can if you think of how these solar cell or what materials are used to prepare or fabricate solar cells, that also one is the important point. This is construction is completed. Now, how these solar cell are fabricated, that is important phenomenon. So there are generally silicon solar cells are used because mostly available material is silicon, cheaply available, and you can use some other using other materials. So you can prepare or fabricate solar cells. Example, gallium arsenide, cadmium tellurium, and gallium indium phosphide. Many are there. Depending on our requirement, we can use different alloys, semiconductor, germanium, silicon, third to fifth group by combining them, by taking alloys, we can prepare them. Okay, generally silicon is used. Okay, in silicon also again you have crystalline silicon, polycrystalline silicon, amorphous. Don't worry about it. What is crystalline? Simply crystalline, if there is a order, that means what? If atoms in the solid are arranged in a proper manner, in a regular manner, then that is called crystal. The atoms are arranged in a proper manner, that is crystalline. And if the atoms are not arranged in different manner, those are amorphous. Okay, clear, understood. If the atoms are created in regular manner, those are crystalline. And atoms are arranged in different manner, those are amorphous. Clear? So, and you remember that is enough. Okay, crystalline and amorphous. These things you remember. Now, you can use gallium or these things. And one more important point is their absorption characteristics. Okay, their absorption. So, mm, okay, maybe some internet problem is there. You can watch it. You just if you are getting the streaming clearly, you watch it. Okay, uh, or it is you can find recorded video in this thing in YouTube. You can watch afterwards even. Okay, so some of the students saying connectivity issue, connectivity issue, and buffering. Okay, no problem. But let it be. We'll continue it. You try to refresh it. Okay, don't worry about it. It is saved in the YouTube channel. You watch it afterwards because I'm trying to explain it is in elaborately in different stages because it is very important and much research is going on in solars to enhance the efficiency because maximum plenty of solar energy is available, abundant till the how much abundant in the sense till universe exists and that day this light is available. So much research is going already fabrication and that advanced techniques are there, but now they are concentrating on how efficiency has to improve. You can check website also, and website is there. I will give in WhatsApp that link. In that website, you can check what is the maximum efficiency. It means how much lighting efficiency. Okay, so anyway, here, okay, I think my side the connectivity problem is there. We'll see. Anyway, recorded video will be available for you. You, if there is any problem, again we'll discuss it. If that recording video also is not good while you watching it, again we'll discuss it because very important. So one what I have discussed is the construction basic principle of solar cell construction part. Okay, the materials, what type of materials are used, and how to choose them. What we have to consider while choosing. The important phenomena is here absorption characteristics of material is important. So the absorption range of these materials should lie in the range of electromagnetic spectrum. So they should, in that way, they should in line with. In that way, you have to choose the materials. Okay, so the matching should be done. The absorption properties or absorption characteristics of the materials should match to the electromagnetic spectrum or solar spectrum, right? And also another important point is it should be cheaper, affordable. It should be cost. If it is more cost, very costly, then of no use. Okay, and you say you're producing electricity using solar cell, and your consumption is electrical requirement consumption is less, but you're investing much amount than what uh, uh, we are getting now. For example, your thermal generation or hydro generation. For that, we are paying some amount. Okay, right. Um, if it is, yes, they should be cheaper than this. In that way, I have to plan. Or if you use solar cell as the source of light, source of energy, electrical energy, and it should be reasonable, should be less cost comparative to other sources. Okay, in that way, you have to choose the materials. So the material should have absorption characteristics in the solar spectrum region, and also it should be cost effective. Should be very the cost should be very less. It should be affordable, right? Understood. This is the one of the main phenomena, important point of choosing materials. Now, so again, what happens here? Generally, already I think you have studied lasers. Okay, when light is incident on material, the electrons in the valency band absorbs energy, excite to higher energy conduction band by leaving a hole. This is a general absorption, right? General absorption. This absorption takes place when light is incident. See in the diagram, when the light is incident, or photon is incident, that is absorbed by the material, and electron hole pairs are formed. Electron reaches to conduction band, hole valency band. This is the phenomena takes place. Okay, this is common absorption or fundamental absorption. Clear? Now, very interesting, very important is its functioning, because already I have studied BEE, and you have solved many circuit problems. Okay, many combination of resistors, capacitors, those things are there. I think you are use it to draw equivalent circuit. There are many number of components in the circuit. I think you have habituated to draw its effective equivalent circuit. Then you will solve it. Okay. So here also we'll do same thing. In this, now I think it is you are able to see it clear. Hmm? This is what our p-n diode, what we use in solar cell. This region is p doped. This region is n doped. This is depletion region. General phenomenon, you know it. This p doped region, in this region, electron hole recombination, major electron hole recombination takes place. And in this region, dark current produces. Right? And this is called quasi-neutral region. Quasi in the sense, neutral charge neutrality is temporary, because electron hole both pair forms, recombination forms. When recombination is formed, charge neutral case, charge neutrality. When they are separated, those are not neutral. Okay, that so it is called quasi-neutral region. This is and this region also. This region and this region are quasi-neutral region. This is depletion region. This is region 1. Depletion region is region 2. Okay. Here in the depletion region, dark current flows. Right. Here, major combination, major recombination takes place. And I will draw, or that I can keep that photo also. Otherwise, right. Wait for a moment. You remember it. Region 1, p-n diode. Other than, see, depletion region is region 2. There dark current is produced. Remaining are region 1, right? Region 1 we are taking as one diode. Region 2 is taking as another diode, right? In that way, I draw the circuit diagram. Only that is also a draw, but not clear. So this is diode 1 representing a quasi-neutral region. main recombination takes place, no? That region. Another is, see, depletion region. Another region is depletion region, and that depletion region is represented with that depletion region is represented with another diode, right? Two diode represents this depletion part, right? Clear? And here, right, across that we can draw the voltage, or we can connect. So now, so I write equation for this is short circuit current, right? If there is no, we don't apply any voltage, whatever the actual current flow that is there in the solar cell is that maximum current. Clear? Okay. This is main the current flow or current in quasi neutral region, main region, current due to major charges, major charge carriers. This is dark current. Okay, and I write it as some I1. This is I2. So total current in the solar cell is I is, if we don't apply any voltages, if voltage is zero, then the total current is short circuit current. Okay. So if you apply voltage, then if you are able to see it, okay. Otherwise, I will read out it. This part is current due to majority charge carriers, right? Current due to majority charge carriers, and that majority charge carriers depends on Boltzmann distribution, exponential term, e power q into v by kt, e power qv by kt minus 1. Okay, this is due to majority charge carriers, and this is of diode 1 in our equivalent circuit diagram. Now, what about dark current? Dark current is the dark current equation is again I some I naught value e power. This is also due to charge carriers, but minor charge carriers. E power qv by 2kt minus 1. But in general calculations, when we are going to discuss VI characteristics, in that case, we don't consider this dark current because it is very less. Okay, very, very minimum. We neglect it. But theoretically, what is happening inside the solar cell, you should know. This is dark current, or it is represented with diode 2. Okay. If V is 0, I is ISM. Total thing becomes 0. Right? Understood? So, this is the basic thing is taking place. This is the solar cell equivalent circuit and basic thing taking place in the solar cell. If you have any doubts, you can ask. You can discuss on WhatsApp. Okay, you can ask. Don't hesitate to ask the doubts because it is very important. And maybe in the examination they ask it. Okay. Now we'll see VI characteristics of solar cell. Wait 1 minute. Let me fix it. Okay. Is it clear? Mm. Okay, we'll see VI characteristics of solar cell. Now, I think you have already in lab, in experimentally you did it. I have taken um, voltage on x-axis and current on y-axis, and as we increase the voltage, how the current is increasing in solar cell. And I think many of you have got very good variation up to some extent, up to some value of the voltage. The current value is constant, almost a straight line you got, and after it drops abruptly. Okay, right? That is we get here. Once we'll see. Okay, on y-axis I and x-axis V. This is the you got the variation like this. This is the thing we got like this, right? Almost the value of the variation of current is almost zero, even though you increase the voltage. And one more important calculation we see here, in the solar cell IV characteristic case, there are three important parameters, three important figure of merits we can say. One is what? Short circuit current. Yes, short circuit current. When V becomes zero, applied voltage becomes zero, whatever the maximum current that is there in the solar circuit, that circuit is ISC, right? Second one is what? Figure of merit, VOC, open circuit voltage. This is VOC, right? Another important point is, another important thing is you have calculated it. Fill factor, beta. This is another figure of merit. Okay, so here you can find a point on the graph where you can point a you can find a point on the graph where power is maximum, right? So according to that, for the maximum power there will be corresponding voltage and current. So corresponding current is, this is Im, corresponding current is Im, this is Vm, right? And here we did not consider the dark current, the current due to diode 2 in equivalent circuit, that we did not consider, right? So here like this the variation occurs in this manner. The variation of the how I and V varies, we already have studied it. Okay, so maximum power point where the voltage at that point is, we have written as VMP maximum. Practically the maybe maximum voltage may not be because after this also, after this point also some variation is there, voltage variation. So should, practically the number is not the thing. What is VMP there? The voltage at maximum power. See in the formula, what is VMP? Voltage. Here VMP we can write if you want. This is V VM or VMP. This is IM or IMP. So how the efficiency will be studied, how the efficiency of the solar cell is known is, the efficiency is eta is is equal to P maximum by P input. What is the maximum power and what is the input power? And one more important factor, okay, see one more important factor here, fill factor. Okay, you know that equation. Fill factor. What is the fill factor equation? Are you able to see it? Okay. What is the fill factor equation? You're right. Fill factor. IMP, maximum power by input power. IMP VMP by ISC VOC. Right. This is the fill factor calculation, and this is about this. What we discussed now is what is the basic principle in solar cell. What is the basic principle of solar cell, and what is the construction of solar cell, and what type of materials are used in solar cell, and how should we how we should choose the materials of solar cell, and construction and equivalent circuit that we discussed, and VI characteristics of the solar cell we discussed. Okay, there are many applications. In the introductory this thing also we discussed applications. Many applications are there because the solar cell produce these are the renewable energy sources, and of course maintenance also very less. This is also one of the use, and durable. Okay, and also these are used in um, street lights, or these traffic signals, or in while construction of roads there, um, for sign purpose, road under construction for sign purpose there, to indicate it, light is required there, they use solar cells. Okay, and solar panels, many of the people, many are using solar cells. Okay, they are converting using solar cell plant at home, at roof. They are converting that energy into electrical energy using it. Many won't see in our town, fencing. If you take any apartment, the fencing and the street light, that is in the apartment lights, are run using solar cell. Also in satellites they are using. That we discussed it. In satellites also they are using the solar cells. So solar cell have plenty applications, need of the hour. Okay, because someday we will be run out of hydro generation, thermal generation, and maybe radioactive uranium generation. If we can get success in converting this solar energy into electrical energy in lowest prices, this will be good achievement. Okay, so this is the class today about solar cell. If you have any doubts, you ask me. WhatsApp message, okay, or phone, call me, no problem. But read it once. If any problem is there in streaming, connectivity problem, you just go through this video, read it, listen it carefully, keep the notes in front, and read it and listen it. If you have any doubts in between, see, today I covered most of the terminology that used in the material, metallurgical junction, a dark current, or a diode, this equivalent circuit, and fill factor, sorry, figure of minutes. These things I covered. Maybe no doubts will be there. If you have any doubts, don't hesitate. Ask. And one more important point: stay at home, be safe. Be at home, be safe. Okay. And also in the morning session, you do some yoga, some exercises, some pranayama techniques. Today, I will share a Facebook page in which they are streaming live yoga sessions from 7:30 to 8:30 in the morning. Recorded videos will be there. Whenever you find time, you just try it. Try it with empty stomach. It is better in the morning to do yoga, do pranayama. It is very important for physical health, mental health. Okay, right? All the best. If you have any doubts, ask. Don't hesitate. right? Good day.